morning. My name is Alshunaif Ibrahim. I'm from King Abdulaziz City for Science and Technology. Today I will talk about one of our research in the National Center of Combustion and Plasma Technology, which is the effect of research, octane number, and fuel system on the performance and emission of a spark ignition engine. This study was done in Saudi Arabia around 91 and around 95 with port injection and direct injection systems. Why this study? As you know, the internal combustion engine powering 90% Ford vehicles and is the main driver in the transportation sector, from which 20% of total world energy is consumed. The engine performance, thermal efficiency, and pollutant emissions have a significant impact extending to the environment. Local and global environmental concerns include increased emitted concentration of carbon dioxide, carbon monoxide, hydrocarbons, and nitrogen oxide that are threats to the air quality and contribute to climate warming. Emissions from transportation sector are considered a cause of greenhouse gases and account for more than 30% of global CO2 emissions, while consuming 63% of petroleum products. Our research aimed to experimentally analyze the performance and emissions of a single-cylinder four-stroke spark ignition engine. This engine is fueled by two grades of gasoline used in Saudi Arabia, research octane number 91 and 95. Also, it's operated by two fuel delivery systems, port injection and direct injection system. Our rig consists of a Lotus single-cylinder research engine, which has a Lotus cylinder head of a combustion chamber of a pent roof type to allow us to shift between direct injection and port injection. The cylinder head, as you see here, has an injector to allow us to do the direct injection inside the combustion chamber, and the port injection is done in the manifold. To record data and compute data, some systems are available, like Horiba gas analyzer, and an ED dynamometer, 30 kilowatt, is available to varying the load. Compression ratio was fixed for all running, and it's 10:1. A series of experiments were carried during this experimental under varying engine speed from 1500 to 3500 RPM with 500 RPM increment at two load, 2.7 and 3.7 bar, and with two fuel system injection, direct injection, and port injection. Engine out data were recorded with maximum brake torque. The engine speed also and load were set and measured. Brake power were computed. Emission parameters as CO, THC, NOx, and exhaust gas temperature was recorded using, as I said, Horiba analyzer system. Very important point to notice, prior to operating the engine with the tested fuel, the engine was operated using the new fuel for sufficient time to ensure the fuel was removed from the fuel system. The result is split in two parties. first, engine performance, and the second one is engine exhaust emissions. Concerning the variation of brake power against the engine speed, we can say that RON 91 produce more brake power than RON 95 across all speeds, as you see here, for the higher load and lower load, and loads regardless of fuel system. Concerning the variation of thermal efficiency with engine speed, the result is that the brake thermal efficiency was found higher with RON 91 and port injection system. Concerning the variation of brake-specific fuel consumption against the engine speed, we can say that the difference in brake-specific fuel consumption was small at low speeds and loads, but significant at higher speed and load condition. Specific fuel consumption with RON 95 is lower. Concerning the combustion duration, the result that can be cited here, that generally combustion of RON 95 is faster than RON 91 in both port injection and direct injection systems. Second, the engine, or the result for engine exhaust emission, if we compare the variation of NOx emission with engine speed at two load, which is 2.7 and 3.7 bar, we can say that NOx emission of RON 91 are higher than gasoline RON 95 in most cases, except with direct injection system at high engine speeds. Concerning the total hydrocarbon emissions, the result that we can say the concentration and the total hydrocarbon or the let's move to the CO. The CO emissions, the CO emissions with engine speed for RON 91 and RON 95 at 3.7 bar load with port injection and direct injection, we can say that CO emission of RON 91 are higher than RON 95 in both fuel systems, mainly at higher load. And to conclude, we can say that the finding can be summarized as the following. RON 91 produce more brake power than RON 95 across all speeds and loads. More brake power was achieved by a port injection system compared to direct injection system, as charge formation is assumed more homogeneous. Brake thermal efficiency was found higher with RON 91 and port injection system. Combustion analysis showed mixed response to different RON and fuel system. Generally, combustion of RON 95 is faster than RON 91 in both port injection and direct injection system. NOx emissions of RON 91 are higher than gasoline RON 95 in most cases, except with diesel, except with the direct injection system at high engine speed. CO emissions of RON 91 is higher than RON 95 in both fuel systems, mainly at higher loads. And last, based on all results, utilize drone 91 with port injection system is advantageous. Our future work consists of doing the same technique and repeat the same condition to analyze the combustion visually. Thank you for your attention, and if you have some questions, I'm available to answer. Thank you.